Here's some examples of where that happens. So let's say a store manager had 4 possible applicants applying for 2 different positions, 2 distinct positions. Okay? Let's just say that those positions are sales clerk and janitor, just to give them a name. And this is happening at some kind of department store like Walmart, I guess. Okay? So 2 different positions, 4 people are applying for it. In how many ways can the manager fill that position? 8?
Mm-hmm.
Yeah?
Mm-hmm.
Okay, how'd you get that? 4 times 2? Okay. Let's look at this in a tree diagram. Okay. So let's say that for the first position, so position, I'm going to zoom in a little bit more. So for position 1, we could have either A taking that position, B taking that position, C, or D. Okay? If A took the first position, okay, then either B, C, or D could take the second position. Follow me? If B took the first position, then either A, C, or D could take the second position. Right, and you continue the pattern along. And if C took the first position, then either A, B, or D will take the second position. And if D took the first position, then either A, B, or C will take the second position.
So there's 12 possibilities.
So there's 12 possibilities, not 8. Like I said, be careful. Okay? So there's 12 possibilities. And remember, these positions are distinct. Think of position 1 as like the janitor, and position 2 as sales clerk. Okay? You don't understand? Okay, so there's 12 possibilities. There's a much easier way to do this. You can use the fundamental counting principle. Let's say you had 2 slots. Okay? This first slot is for the janitor. And the second slot is for the sales clerk. Okay? Or position 1, position 2. How many people could be chosen for the janitor? If no one has been hired yet? 4 people. Okay, 1 person gets hired. How many people could be chosen as the sales clerk, given that 1 person has already been hired? 3 people.
So it's like the
And then the product of those,
cards thing.
it's like the 52 cards thing. Yeah. Okay, so again, so this 12 positions. So this is a lot faster than drawing a tree diagram. But the tree diagram helps to maybe prove that there are actually 12 positions. Here's another one. In how many ways can a teacher seat 4 girls and 3 boys in a row of 7 seats if a boy has to be on either end of the row?
Oh, it doesn't make me mad.
Okay, I'll read that one more time. You've got 7 kids sitting in 7 chairs. 4 of them are girls, 3 of them are boys. And you need a boy on either end. How many ways can you do that? Here's an easy way to do this. Draw 7 chairs, or just 7 blanks for 7 chairs. 1, 2, 3, 4, 5, 6, 7. Good. Okay? So you need a boy on either end. How many boys are there? 3. Okay, so for this chair, we'll put one of those boys. There's 3. One of 3 boys is going to sit in those chairs. In that chair, sorry. At the other end, if I've already seated a boy here, how many boys do I have left to sit here? 2. Okay. Good. Got that taken care of. From there, it doesn't matter whether a boy or girl sits in whatever chair in these middle 5 seats. It doesn't matter. Right? So how many people do you have left to seat? You have 5 people left to seat. Right? So for this first chair, there are 5 people who can sit there. The next chair would be 4 people who can sit there. 3, 2, and then the last person always has to sit there. You could have like boy, girl, 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 girl. You could have girl, boy, girl, girl, girl. Right? Girl, girl, boy, girl, girl. It doesn't matter. Okay, you just have 5 people sitting in those chairs. How many ways can you do that in those 5 chairs? To find the total number of ways to do this whole arrangement, multiply all these numbers.
720.
You're kidding me. I said 750.
So 4 is the wrong answer. That's a lot, right? And
My goodness.
and writing all of the possibilities would take a long time.
Okay, so
How many different ways are there to arrange 10 students just standing in a line? This is a little easier. Again, just imagine you have 10 positions. 3, 4, 5, 6, 7, 8, 9, 10. How many people can you put in the first spot? 10. One guy stands there. How many people for the second spot? 9, 8, 7, 6, 5, 4, 3, 2, 1.
3,628,800.
yeah,
What is it? 3,628,800.
800, yeah.
That's a really large number, right? It almost doesn't seem like that's possible.
It isn't.
But if you tried to, believe me, if you tried to start trying to write all the different ways you can arrange 10 things, you will be there for a while. You will be there for a while.
Now I kind of believe your card thing.
Okay?
No, I still don't believe your card.
Still don't believe my card thing? I'm going to show you the card thing again. Okay? D, how many ways are there to create a 4-digit password if there's no digits repeated? Okay, so again, 4 slots. How many options do I have for the first digit?
4.
4?
9.
No.
Only 24
Infinite.
ways.
So these.
Oh, 9. What?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
10.
I've got 10 options.
0.
Yeah, right? There's 10 digits. From 0 to 9, there's only 10 digits you can
my
use.
God.
5,040.
It says 4 digits.
How do you do that then? 'Cause
Okay? I use a digit. I can't use it again, so my second slot, I can only use 9 possibilities. Use another digit. I've used 2 already, so I can only use 8 for the third and 7 for the fourth.
No wonder it's so hard to.
Like I said, tricky.
Wait. So what about 6?
I'm not using the number 10 here, or the number 9. This is the number of options I have.
I know, but you still have.
I'll always have 6 digits I haven't used. Because possible passcodes could be things like 8104. Well, I used 8 and 1 and 0 and 4. But I didn't use 9 or 7 or 3 or 5 or 2 or anything like that. Okay, so how many possibilities do I have here?
too many.
5,040.
5,040? Possible passcodes with no repetitions. If you did have repetitions, how many passcodes could you create?
10 times 10 times 10.
Yep, 10 times 10 times 10 times 10, so 10,000. So just the fact that you're not allowed to use the same digit almost cuts the number of possibilities in half. Pretty amazing.
Crazy talk.
Crazy talk
So
indeed.
you have a better chance in guessing somebody's PIN code to their debit card than winning a lotto.
Oh, definitely.
So why don't we just
Far greater chance.